Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever for the binomial theorem, part 2. We're going to finish this up. Let's get to it, shall we? Still enjoying Men at Work, Be Good, Johnny. All right, things get a little dicier here, but it's not too terrible. We are being asked to find the coefficient of x to the 6th power. Okay, what does it mean, coefficient of x to the 6th power? So let's just ignore this for a second. And let's just say I had some polynomial, I don't know, like 12x to the 8th plus 17x to the 7th plus 32x to the 6th minus 47x to the 5th minus, and so on. Well, the coefficient of x to the 6th is this number, 32. So if I was just being asked, okay, look at this polynomial, what's the coefficient of x to the 6th? The answer would be 32. Okay? It's a little more complicated than that, but I just wanted to make sure that we understood what it is that we are being asked to find. So let's think about A, the coefficient of x to the 6th power. This is the key here. Okay, I need to find this term. And in order to find this term, I need to find r. Because if I can find r, I have everything that I need. Because I know that a is x squared. I know that b is 4 over x. And I know that n is 12. Because 12 is the power of expansion. So all I need now is r. So to find r, I'm going to use this handy-dandy formula. T sub r plus 1 is equal to n choose r, a to the n minus r, b to the r. Okay? So let's substitute in what we know. We know that n is 12. We do not know r. That's what we're looking for. My a term is x squared. So that's going to be x squared to the n minus r, or 12 minus r, times 4 over x, the b term, to the r power. And again, I don't know what r is. So let's clean that up a little bit. Then we'll stop and talk about it, get some strategy here. I am going to simplify this using the laws of exponents. X squared to the 12 minus r. Exponent raised to an exponent, we multiply, so 2 times 12 is 24, and 2 times negative r is negative 2r. And here I have, let's see, 4 to the r over x to the r. That's kind of a poor r there. Okay, let's see if I can do better. That's a little better, 4 to the r. All right. Now, we are looking for the coefficient of x to the 6th power. So I really only need x here. What do I mean by that? Well, let's take a look at this. If I clean this up a little bit, 12 choose r. I think of this as over 1. It's a numerator times a numerator, denominator times a denominator. So I could think of this as 4 to the r times x to the 24 minus 2r over x to the r. 1 times x to the r is x to the r. Well, now, all I need is my x term, because 4 to the r is not going to produce another x. Neither is 12 choose r. Well, let's think about x to the 24 minus 2r over x to the r. Well, isn't that equal to x to 24 minus 2r minus r? Remember, x to the a over x to the b is equal to x to the a minus b. So I'm just taking exponent minus exponent. So that equals x to the 24 minus 3r. And if I stick all that back in here, I have the term 12 choose r times 4 to the r times x to the 24 minus 3r. So this is just kind of scrap work for simplifying this part of the term, just the terms involving the x's. Now, we are in business here because we need the exponent to be equal to 6. Well, the exponent right now is 24 minus 3r. Well, 24 minus 3r has to be equal to 6. Solving that, negative 3r equals negative 18, and r is equal to 6. Okay, now, is it always the same as the exponent? The answer is no. That is just a coincidence. So, the coefficient of x to the 6. Well, let's fill all of this in and remember what coefficient means. So instead of 12 choose r, I now have 12 choose 6, replacing r with 6. I have 4 to the 6 times x to the 24 minus 3r. We already know that 24 minus 3r is 6, because that's exactly what I was looking for. So the coefficient is the number in front of x to the 6. So the coefficient is actually 12 choose 6, 4 to the 6th. All good. Okay, so that's my answer right there. That's the coefficient. And if I had a calculator, I could simplify that. And in fact, I will do that for you. That's equal to 3,784,704. 3,784,704. If you do that in your calculator. You can check me out on that. B, the constant term. Well, the constant term, remember, we have our general term here. We have 12 choose r, 4 to the r, x to the 24 minus 3r. Well, the constant term means there's no variable. Well, the only way I'm going to get rid of this variable is if this is to the 0 power. I need x to the 0 power because x to the 0 equals 1, and so then I will not have any variable. I will just have 1 times 4 to the r times 12 choose r. Well, what do I do there? I simply need the exponent, 24 minus 3r, to be equal to 0, and if we solve that, we get r equal to 8. So my constant term would be 12 choose 8, 4 to the 8, right here, replacing r with 8, x to the 24 minus 3 times 8, or 24 minus 24, or 0. So that would be 12 choose 8, 4 to the 8th, times 1. And if you put that in your calculator, you would get 32,440,320. 32,440,320. All right, last example. Find the coefficient of x to the 5th in the expansion of x plus 3 times 2x minus 1 to the 6th. Okay? So let's think about this. So I have x plus 3, which is just to the first power, and I have 2x minus 1 to the 6th power. Okay? And I need the coefficient of x to the 5th. Now, in this case, I don't need to get the general term. I just have to think about it a little bit. What I need to do is expand this. There's nothing I can do with this until I expand this. Okay, so let's think about what this is going to be. So this is x plus 3, and we start expanding this. This becomes 2x to the 6th power, according to our formula here. Hopefully we're used to this now, and this becomes 6 choose 1 times 2x to the 5th power times negative 1 to the 1st power, because my a is 2x and my b is negative 1, plus 6 choose 2, 2x to the 4th power times negative 1 squared plus 6 choose 3, 2x cubed, negative 1 cubed, plus, and so on. And I'm going to stop there, and actually I didn't even need this term if I'm able to think about it a little bit. Okay, again, I need the coefficient of x to the first. So if I have expanded this, the next thing I would have to do to keep expanding is multiplying every single term in here by x, and then again by 3 and combining like terms. If I take x times 2x to the 6, well, the x is going to be multiplied by x to the 6 and get x to the 7th. Well, that's not x to the 5th, so I don't worry about that. Again, x times x to the 5th here gives me x to the 6th. That's no good. But x times x to the 4th gives me x to the 5th. So I have to consider this term right here. Okay. And then I also need to think of the 3 that doesn't have an x in it. So 3 times this term, the 3 is not going to change x to the 5th power. So I have two terms that are going to work here. I'll go ahead and do this one first. 3 times 6 choose 1 times 2x to the 5th, the whole thing to the 5th, times negative 1 to the 1st. And I also have x times 6 choose 2 times 2x to the 4th times negative 1 squared. Okay, so let's clean it up a little bit. 3, 6 choose 1, 2x to the 5th would be 2 to the 5th, x to the 5th, and negative 1 to the first power is negative 1. I'm just going to move that in front. If I multiply 3 times negative 1, it's just negative 3, plus 6 choose 2. Oops, this 4 should be all the way out here. Sorry about that. So this would be, I'm going to distribute the x here in a second. So 2 to the 4th power right here, and then x to the 4th power. Now I'm going to move this x here conveniently, okay? Because x to the 4th times x would give me x to the 5th. So I'm just going to rewrite that as x to the 5th. And then negative 1 squared is a positive 1, so I don't have to worry about it. Okay. Well, this becomes, if I factor out x to the 5th, then I'm left with negative 3, 6 choose 1, 2 to the 5th, plus 6 choose 2, 2 to the 4th. Think about it. If I take this times this term, I get negative 3, 6 choose 1, 2 to the 5th, x to the 5th. And if I take x to the 5th times this, I get 6 choose 2, 2 to the 4th, x to the 5th. And I'm just going to take that and move it here just to re-emphasize that I now have my coefficient of x to the 5th right there. And if I take my calculator and punch in negative 3, 6 choose 1, 2 to the 5th, plus 6 choose 2, 2 to the 4th, negative 336. And that is the coefficient. So the term would actually be negative 336 x to the 5th, but they asked for the coefficient. All right, that is all I have. I hope you enjoyed it. We are done with the binomial theorem as far as videos go, and I am out.